Step 3, data preparation. Now, we choose the relevant data for the project, we clean, integrate, and format the data. How the data will be prepared depends partly on the model we will be using. So this step prepares the data to be fed to the model, to the algorithm. So it must fit into the model's parameters. That is why this step is iterative with step 4, modeling, remember in the CRISP DM. So step 1, or for us, step 1 will be cleaning. So that involves removing any irrelevant data points, things I don't think have anything to do with attrition. For example, removing employee numbers, employee names from our data, because that's not something that predicts attrition, right? Integrate. If there's any data points from other sources, make sure they're correctly integrated with our data set. In our example, we don't have this issue. Lastly, format the data. Make sure the data is in the correct format. Any integers need to be converted into strings and are categorical for the purposes of our model and our question. So here is a continuation of our previous screenshot in Knime of the modules we're using. So you can see I linked from the reader number to string and domain calculator. These two are preparing our data to be put into the model we'll be using, which leads us to our next step. Step 4, modeling. Selecting the right model, also known as algorithm, testing the model, and assessing how well it performs. Now, this is a very similar process to America's Next Top Model, but maybe with a little less drama. So this step can be daunting to both new and seasoned analysis. To understand what model should be used, it is essential that we understand the problem and the question we're trying to answer. And remember, that question is, what employees will leave, right? So the answer is going to be yes or no in the attrition column. So that makes this a question of classification. It can be in one of two classes, yes or no. Now that we know this is a classification problem, we can narrow down our potential models used to classification algorithms like logistic regression, support vector machines, naive Bayes, decision trees. But for this presentation, I'm going to focus on random forest classifiers because it uses a logic that many of us are familiar with. And here I show a chart that many of us have probably been exposed to something similar of breaking down questions. You can see, should I do my laundry? That's their big question. Are you an adult? Yes. Are you a dirtbag? Yes. You don't have to do your laundry. This is a silly example. However, it uses a logic very similar to the model we will be using, the random forest model. So like this laundry decision chart, a decision tree splits current observations so that the resulting groups are as different from each other as possible. And the members of each resulting subgroup are as similar as possible. The random forest model uses many different decision trees to gain a consensus on what the classification should be. The benefits of using a random forest model include that it's accurate, it's easily adaptable, it's not prone to overfitting, and it is somewhat interpretable. However, it is slower than other models, mainly a problem with huge data sets. For our example, we do not have a huge data set, so I'm not concerned. So just like in step 3, you can use your Knime software to run this model for you. And here is a screenshot of our modeling in Knime. So we've prepared the data, and now our first step is to partition the data. that is to split it into a test and a learning modules. Or excuse me, a learner and predictor data set. We feed the learning data into the random forest learner. This teaches our model how to behave. Then we can take the model output and actually test it out. How well did our model do on this data it hasn't seen yet? So that is our modeling, and I will say then we can view our results and we can also score our data, see how well it did, which I'm going to talk to in our next step, evaluate. Evaluate. So this is when you take a moment and you step back from the computer. Did we meet our beginning goal? Are we answering the question we set out to answer? Remember, our goal was to know what employees are likely to leave. We used a random forest classifier to predict the class each employee falls into. Yes, they're going to leave, or no, they're going to stay. I believe we answered this question that we set out to answer, so we can move on to our final step, which is deployment. You can see here, this is a screenshot of my random forest random forest predictor module in Knime. Now, we can create a plan to deploy the model, make our information accessible to others outside of this process, and maybe create a report. So, again, for this project example, we would need to be mindful of how sensitive the data is. That's why I don't recommend actually doing this particular problem on your employees. It would open up a good lawsuit discrimination case, but this is fictitious. This is for learning. So, we would, though, take note of the departments that have the highest attrition rates and maybe prepare for cross-training employees in that department. In closing, we use the CRISP DM methodology to answer the question, will this employee leave the company? We used Knime analytics software to complete this. Thank you for your time. I appreciate it.